Okay, some of these, when you guys do this practice multiple choice, it changes the order of the questions. So this probably wasn't your first question, but just go with it. All right, so here's the velocity versus time graph, right? So be very careful there. And they want to know the acceleration. So that's going to be the slope between t equals 0 and t equals 4. So what is the slope of that line? Well, our change in y over our change in x. Change in y, we go up 4. And our change in x, we go over 4. So we've got 1 meter per second squared. That's B. Okay, again, this is going to be different than yours, and that's okay. So here we go. We've got, this is a position time graph. It moves along a straight line. During the time shown, the speed, okay, speed, that's not velocity. Remember, speed is going to be the absolute value of velocity. So just a little vocab there. The speed and acceleration of the object will have which of the following characteristics? Okay, so speed. Our speed is going to be the slope of that line. Our velocity is the slope of that line, okay? Our velocity, so we have a straight line here. Our velocity is going to stay constant. So our speed is going to be constant. And it's not 0. Okay, so then either, hold on. So either we have to have an increasing acceleration or we have to have 0 acceleration. Well, if speed is constant, that means the acceleration has to be 0. Okay, acceleration is just how fast something is speeding up or slowing down. So if it's not, then it's 0. So it can't be this one. So it's D. The constant, we've got a constant speed, which is not 0, and then we've got a 0 acceleration. All right, great. Next one. Alrighty, we've got a velocity time graph. First of all, the graph above left shows velocity. Be very careful. Velocity versus time for a particle moving in a straight line. Graphs of displacement versus time. Okay, so that's the same thing as position. So which ones match that? So basically, here's the deal, right? We know velocity is going to be the slope. Velocity is the slope of our position time. Okay, the other way we can find position from velocity is to calculate, okay, here's the position at t equals, t1. Here's the position at t3. Like we would find the area. So we can see if you even think about it, if you have this velocity is constant, right? So if we travel at a constant velocity, we're going to move up, we're going to have a line, right? So if velocity is the slope of xt, right, position time, and this has the same slope the whole way, the only thing that has the same slope the whole way is a straight line, like this or like this. It can't be a curve like that. So it's 1 and 2. This one. A ball is thrown straight upwards, a baseball. What's the acceleration at its highest point? Sorry, guys. So when something is thrown upwards, as soon as it's let go, it's in free fall. Whoops. And its acceleration is g, and that's always pulling down. So where's g? G downward. Automobile starts from rest. It goes on a straight road. So this is a distance time graph, not displacement, but distance, but that's okay. From the starting point is given as a function t. Okay, so this is a position time graph. During which interval is automobile stationary and farthest from its starting point? Okay, stationary means its velocity is 0. Okay, this is when there is a slope of 0, because remember the slope of position time gives you velocity. So that would be D. Alrighty, now we've got a position time graph again, right? Pay attention, position as a function of time. Pay attention, pay attention. Oops, sorry, time. Which of the following graphs of velocity v as a function of time describes the motion of this particle? All right, so here's the deal, right? We've got a curve. We've got a curve for the first part, so I'll put that in green. And then we've got a flat line for the second part. So let's say you're like, what is that curve? I don't like that. So let's remember that the slope of position time is velocity. So let's start with that blue part. The slope here is 0. So that means we have to have a 0 velocity, v equals 0 after the time t1. That time t1. Okay, so let's look. This has a velocity greater than 0. Goodbye. This has a velocity less than 0. Goodbye. This has a velocity of 0. We'll keep it. Okay. This has a velocity of 0. Keep it. And this has a velocity of greater than 0. Goodbye. All right, so it's either C or D. Okay, so what we've got, let's think about this. In C, we have a negative velocity, right, to start off with. And then we have, in D, we have a positive velocity. So let's try and think. If we had a negative velocity, that would mean we were moving in the negative direction. But up here in that green part, right here, we can see we're moving in the positive direction. So we have to have a positive velocity. So that's D. You can also tell that actually, if you use tangent lines, right? So here's my tangent line at t equals 0. Here's my tangent line right there, right before t1. The tangent line, the slope is increasing, so the velocity is increasing, and all those slopes are positive. All right. So these are, you got to pay attention here. We've got position time, position time. Then we've got velocity time, velocity time, velocity time. So in which of the graphs does the moving object reverse its direction? Okay, so let's look at the position time graphs. As time increases, we're going up the whole way. Okay, so this is always in the positive direction. So that can't be it. For this one, as time increases, we go up, 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 up in the positive direction. We never come back to the origin, so that's a no. All right, velocity. Remember, negative velocity means negative direction. Positive velocity means positive direction. So we need one where it's reversing its direction, meaning it moves in the negative direction and then goes to positive, or it moves positive and then goes to negative. So this is all negative, so that is not it. This, look, we've got some positive, and then down here we've got some negative. Woohoo, that works. And here it's all positive, so that can't be it. So it's D. Man, we've got a lot of D's here, you guys. A piece of chalk is thrown upwards and caught during its descent. This is free fall, friends. From the same height in which it was thrown. Position is measured from the location of the chalk when it left a hand. The positive direction for position, velocity, and acceleration is upwards. What are the signs of the position, velocity, and acceleration during the descending part of the trajectory? So this would be the negative part, right? Okay, so let's take a picture of this. Not a picture, but here's the chalk, and it goes up, right, and then it comes back down. Okay, so upwards is positive. So in the descending, we know it's falling negative. So this direction it's moving in is negative. That means velocity is negative. The acceleration is going to be the acceleration due to gravity, which is always pointing down. So acceleration is negative. So let's see. Let's see, position. Let's look at velocity. We need negative velocities. And we have to have negative acceleration. So the only choices are C and E. Here's the deal, right? Okay, so anything above, because the positive direction is up. Anything above the ground is going to be a positive height. So even though it's coming down, it's just going from its max height, whatever that is, down back to your hand. Your hand doesn't have a negative doesn't have a negative position, negative height. It's not below the ground. It's positive. So it's going to be E, positive, because the position is always above the ground. That's basically what that means. All right, take a look at that velocity time graph. So velocity, okay, the displacement between t equals 0 and t equals 8 is displacement or position. So x is the area underneath the curve, you might have heard us call it, or between the line and the horizontal axis. In this case, it's going to be positive because it's all above the horizontal axis. So I'm going to divide this. This is a trapezoid. I can either divide it into a triangle and a square, a rectangle, or I can treat it as a trapezoid. I choose this. So let's do, the triangle be orange, not orange, wow, pink. And then the rectangle be green. So the pink is 1/2 base times height. That's going to be 1/2. The base is from 0 to 4, which is 4. The height is from 0 to 4, which is 4. So 1/2 of 16, which is 8 meters. All right, and let's do the green. The green is just base times height. And the base is from 4 to 8, which is 4. The height is from 0 to 4, which is 4. So we've got 16. We're going to add these together. 8 plus 16 equals 24, which is A. All right, we've got some more of those displacement. We had these before. This is a little bit out of order, which is totally fine. Okay, so we want to know, oh, come on, in which case is velocity constant? So to get velocity from our position time graphs, we need to find the slope. Okay, the slope of a straight line is always going to be constant, right? So I could find, if I used these 2 points to find the slope, it would be the same as if I used these 2 points to find the slope. Any of those 4 points you could use to find the slope and it would be the same. So this is a constant slope, so this one works. So this is a yes. Here, we were already talking, this slope and this slope are 2 different slopes. So that's not a constant slope, not a constant velocity. All of these 3 are velocity time, and none of them have a constant velocity. It is decreasing, decreasing, and increasing. So no, no, no. It's just A. Here we go. 2 trains on parallel tracks, same starting position. So train X has a constant acceleration and train Y has a constant velocity. So look, this is a position time graph. Position. The graph shows their respective distances from the starting point as functions of time. At time t, that's right here. I'm going to actually erase that because now you can't really see. So at this time t, right here, you can see that both lines are at the same place. They've gone a distance d. So we know train Y is not ahead of train X, and train X is not ahead of train Y. So it's got to be one is moving faster than the other. So let me draw their tangent lines at that point. Train X will be in pink. That looks like that. Train Y, I mean, that's not great, but whatever. Train Y. No, we're not doing yellow. One of my AP kids was using yellow the other day, and I yelled at her, so I don't know why. I just did yellow. That'll be in green. All right, so the green one looks like that. So, oops, the steeper slope, you guys, is pink, right? This is steeper, which means that it's faster. So train X has a steeper slope, which means that it's a bigger slope, so that works. So it's X. X is moving faster than Y. Next. How many of these we have left? Oh my God, 5. Alrighty, so same 5 graphs we've had twice now. Which of the graphs is equivalent to the distance time graph shown, right? So, okay, for one of these 2 to be equivalent, it would literally have to be the exact same thing. They're not. Goodbye. Okay, now let's look. if we take a look, so now we're going to compare these velocity time graphs to this position time graph. We know that v is the slope of the xt graph. So let's take a look. We got to find the tangent lines. So I'm just going to draw, this is my little, whoops, that's not a great tangent line, you guys. So right at the start, right at t equals 0, this line here is a flat horizontal line that has a slope of 0. So we need to start with 0 velocity. V equals 0 to start. So this starts at v equals 0. This starts at v equals positive something. And this also starts at v equals positive something. Goodbye. So it's got to be c. That's it. We also know that the speed, if you look like down at the end, it's got a steep negative speed or velocity. In the middle, it's got a velocity negative, but not quite as steep. So it keeps getting more and more negative, I suppose. Okie doke. Two trains, X and Y, are moving on parallel tracks from the same starting position. This is the same thing. We've had this before. So if both trains continue with the constant state of motion, which is true, remember we knew that X is moving faster than Y. That was a few questions ago. Okay, at time t. Okay, so let's take a look. Does train X move faster than train Y at all times after t equals 0? No. Right here, obviously it doesn't because it's moving faster than train Y there, but they start at the same time. If it was always moving faster, it would be ahead of it. So no, that's not it. Train Y will reach the distance 2d before train X. Probably not, because X is just continuing to get faster and faster. So if they keep going, then train Y will reach that distance faster. So that's this one, C. Let's just double check. Part D, train Y moves faster than train X at all times after t equals 0. Wrong, because in the last one we figured out train X is moving faster than train Y at time equals t. So it's C. Only a few left. Thanks for sticking with me. Two cars, A and B, are moving from their starting line at time t equals 0 and race over total distance d. The graph shows their respective distances from the starting line as functions of time. Okay, what are the correct statements? At time t1, car A has a greater speed than car B. Let's test that out. So t1, okay, here's car A's speed, because again, it's the slope. Here's car B's speed. Nope, car A has a greater, let's see. So yes, this is a yes, because A slope for car A is greater than the slope for car B. So yes, it has a greater speed, right? Remember, to find the speed, we just find the slope of these distance or displacement or position graphs. Okay, so if we go down here, 1 is right, so it can't be B or D. Really, we just have to test number 3. Car A crosses the finish line first. So the finish line is the finish line. The finish line is D. Which one gets there first? Let me erase what I drew. Okay, car A gets to the finish line here. Okay, I don't know what time that is, but car B doesn't get to the finish line until here. So car A has a smaller time, which means faster. So yeah, that's true too. So it's that one. The middle one at time t1, car A is closer to the finish line than car B. No, because they're both at the same distance. You can tell they have the same like vertical value, and the vertical value is distance. So no, that would be wrong. All right, 2 more. A piece of chalk. We already talked about that chalk. So remember, this was you standing here with your chalk, and it goes up and then it comes down, positive. Sign is that way. Okay, so we already talked about how acceleration is always negative during free fall. If it's ascending, that chalk is going up. And we already talked about how you're above the ground. So everything above that is a positive position, so your X is also positive. So we're looking for positive, positive, negative. Nope. 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 Gotta be D. Last one. Okay, automobile, mass of 1,500 grams, is traveling on a flat level road. The graph shows the speed which we can also interpret as velocity for now, as a function of time. The automobile's acceleration at the end of 60 seconds is, so acceleration is the slope of the VT graph. So all we need to do is find the slope of that. So our slope m equals change in y over change in x. So our change in y is about 15. Our change in x is 60. Okay, that is 1/4 or 0.25 meters per second squared. Great, for a second I got nervous. Let me just double check. Yeah, that seems right. All right, and that's it, my friends. Okay, have a good one.